Take a moment over here, make sure I see it on the good old Twitch side. It does look like it. Okay. All right, it is a good day for OBS. So today's 9/5. We're still in week 3 here of CSE466 at ASU. The module that launched a couple days ago, we were talking about reverse engineering. The slide deck that I had on Tuesday, we didn't get a lot of time to actually talk about reverse engineering. So this deck's going to be a lot shorter. So hopefully we can get into some more application-focused things. Memes. So some people have realized that they are spending a lot of time here and kind of neglecting other courses. That is a common pattern. We are on the other side of the drop deadline. I said ballpark drop rate, or percentage of registered students that stick it out is somewhere between 40 and 60%. That number is at the end of the course. So there's still obviously a withdrawal deadline months down the road. But as of the other side of the drop deadline, 45% of the initial registered students have dropped the class. Just so you know, it's right in expectation. I wasn't making up these numbers. We're good. I'm not going to give any more spiels about things being scary and hard because it's a waste of time. At this point, you've decided you want to ride the train, so the train's going to move forward. We're going to focus on content. One thing I do like to talk about is kind of progress, how people have worked on the current module. So it's been out for 2 days. 44% of the class hasn't started. I'm not worried about it. You work over the weekend. That's totally reasonable. Those that have started on it, when I say started on it, I mean they've solved at least one. So if I just exclude the students who haven't solved anything, they're about halfway through. They're 48% through, which is a good sign. I did say on Tuesday, this is one of the harder modules traditionally, where it does take some time. Student reception has been kind of the opposite. They've been like, hey, this is actually not bad. I'm cruising through it. That's a great sign. We'll still spend 2 weeks on it either way. For this module in particular, this is going to sound like an instructor, all my work is important, but it's really not bad. It's not self-inflated. I strongly encourage everyone to try and complete all of the challenges. In this module in particular, the reason is because of YON 85, which is what everything from 12 onward is, which is everything that's assigned. In particular, level 19 and beyond. So YON 85 is kind of a vehicle to understand reverse engineering for this module, but it will reappear in later modules. So now is the time, even if you are crushing it and kind of working ahead and getting stuff done, to make sure that you have a good understanding of how this thing works, because we are going to use it as an example for other concepts going forward. It's not going to be in every module, but it's better to wrap your head around it now, so that way you're not fighting it again and again and again whenever it reappears. My personal recommendation as far as how you can optimize for the future is to try and write some type of simple assembler or disassembler. Does anyone want to tell me what I mean when I say that? Okay, the statement for Twitch here was converting YON 85 to bytes. So in 13, which is the first level that actually starts kind of introducing the YON 85 concepts, it has that printout, right, where it says move whatever. We took a look at it on Tuesday briefly. Those are like the instructions that one would type in this assembly language. But those instructions map to some type of literal byte. And so an assembler would allow you to write that high-level IMM A42 or whatever, and then your code will interpret that and then output bytes, right? It kind of lets you speed run this stuff. The first level is up until 18. It's not really necessary. If I remember right, 19 is the first level where you start having to deal with the raw byte representation in the challenge itself. And this is a strategy that if you deal with it now, it'll just save you pain down the road. So I definitely recommend giving that a shot. Like I said, doing it now, you pay dividends down the road here. Logistical things. I did submit that room reservation. They're trying to get me on a different day and time than the Friday at noon. I'm pushing back. Once I have a room, I'll let you know. Like, I don't think it's going to be a major issue. It just has to go through a more lengthy process. If I don't get it back by tomorrow, I'll still just be streaming, and we'll deal with it that way. One thing that I've kind of noted, I've dropped in, I think, at one recitation each week so far. Hasn't been the same day. CSE466 is not having a strong presence. There's definitely people I've seen there and talked to and said, hey, are we good? I'm getting people unstuck. But it is a great opportunity if you have, I am hard stuck on this. If you're at recitation, someone can sit down with you and explain what's going on in your code and try and help you fix it or understand it and reason about it. Right there, it'll be a lot more catered to your individual scenario than what you'll get here in class. So if that is what you're looking for, I'd strongly recommend giving that a try. Again, it's Monday, Wednesday, Friday. One of the issues I kind of discovered showing up to these is that there is mixed 365, 466. I'm going to flag a table as just for 466. So that way, if you do show up, we have some idea that, hey, this table is interested in 466 stuff. So we can prioritize, the people that know 466 content can prioritize that table over anyone else. So one of the tools, who started on this and they've used a decompiler, they fired up IDA, Ghidra, something like that. Cool, everyone. I love to see it. One of the things that is a little bit difficult here from an instructor standpoint is what tool do I show you, right? I'm not going to say any particular tool is better than the other. There's a trade-off to why you would want to learn any of them. And there are decompilers and tools that are not on the dojo, but I'm going to quickly hit some pro cons on the tools that are there and why you may want to use that over a different one. So IDA is the first one, and that is probably what you're using because it is kind of the gold standard as far as what is the result when I hit tab and I get something that looks like C. It tends to output the best decompilation without you doing that much work. With that said, it absolutely can misinterpret something and you get something that looks like garbage, right? With a whole bunch of casts and weird stuff going on. The free version, which is what is on the dojo, uses a cloud decompiler. Now, the reason that I bring this up is if we approach the deadline and everyone is using IDA and they hit tab, this thing will time out. Their cloud server will just say, there's been too many requests lately, wait. That isn't us on the dojo. That is the free version of that tool just saying, too bad, right? We've done all the free requests we're going to for a while. So know that's a limitation if you are relying on that tool in the back half of the deadline window here. If you are thinking about working with this stuff long term, the paid version pricing of IDA is quite expensive. All right, IDA has a reoccurring kind of yearly licensing model. And the audience that they're targeting tends to be large commercial organizations. And so if you are interested in using this as an individual, it's probably out of your budget. It's out of mine, right, to get a paid IDA Pro license. But with that said, it is the best tool. But just know that as you're learning it. Another option that you can learn is Ghidra. Ghidra is used by the NSA. It's their open source decompilation tool. Open source is awesome. One good thing here is it's written in Java, so that means no matter what your platform is, you'll get the exact same experience. Because it's open source and it's highly extensible, there's a lot of plugins and a lot of community contributions for very hyper-specialized scenarios where somebody wants to, for instance, debug some firmware. Somebody will probably wrote some plugin that will map whatever it is your problem is into Ghidra. And in that sense, it is a bit more of a Swiss Army knife than something like IDA Pro or the other options because of its kind of open source and editable nature here. If you use Ghidra, the decompilation happens locally on your computer, so you don't run into these cloud problems. So if at the end of the deadline here, you're running IDA and it says cloud fail, fire up Ghidra. It's going to run it locally, right? That's kind of your escape hatch there. The other thing is the workflow is a little bit different. So when you have IDA, you have one big pane. You hit tab to hop back and forth from your C to your assembly. Ghidra's workflow is side by side. So you have one pane that is the assembly and one pane that is the decompilation or pseudo C. And then as you change things in one, it updates the other, which can be a very good workflow, right? It's personal preference there. Binary Ninja also has a free version that is on the dojo. Binary Ninja is a pretty fancy looking tool. It's got a modern UI, so it looks clean, which I kind of find enjoyable to use. The paid version, though, IDA does have its own scripting thing. But in particular, Binary Ninja has a pretty powerful scripting plugin language if you want to start working with decompilation programmatically. And that is one reason you may choose to use Binary Ninja. They have a pretty big community where they work on some of these things. The paid version has many intermediate representations. So instead of just having the assembly and the pseudo C, you can look at some of those middle steps if those make more sense to you as far as how are they mapping assembly to something else to get up to C. And sometimes that helps inform you about what's really going on. In contrast, it is a paid product. The commercial version at least. The pricing structure there, they are targeting individual users. So if you're looking for something that you're going to pay and use down the road to try and do reverse engineering, the pricing structure definitely matches what is, I think, a bit more reasonable for an individual user. Lastly, I'll mention anger management, which is also on the dojo. Anger management is a UI that wraps the anger project. The Anger project does a number of things. It's a research prototype would be the kind of the way to talk about it. It does binary analysis, it does symbolic execution. It does a number of additional features than just a decompiler. A lot of the work that goes into anger and anger management is actually done by the CEFCOM lab here at ASU. So you will get to, at least when something doesn't work, you have someone to complain to. Downside is that it is a research prototype. So there are a lot of experimental things that kind of get thrown in there. It's on the cutting edge. Sometimes things break, sometimes things regress. It's not a commercial product. So your mileage may vary, but it's also free, open source, available if that's what you choose to use. Just out of curiosity, is anyone here not using IDA? What are you using? You're using anger management? And you're good?
Sometimes it takes some minute to decompile, but it decompiles. At this point, I haven't faced any issues.
Okay. So for Twitch, the feedback was, hey, it gets what I need done. Sometimes it takes a minute to actually do the decomp. If there is something in particular that doesn't behave how you expect, I do know one of the primary developers of the project, and they've asked me if there are major pain points to surface that to them. So if there is something that you find, let me know, and I'll pass it on. Okay, that is it for slides. So, my demo plans, first off, is there anything that you are stuck on that you want me to show? Okay, everyone seems to be moving and cruising. You got a hand?
Well, I was doing 12.0, and then there was this IDA, but then I got to the part where I found the buffer with the characters, but I'm not sure how to decode that properly.
Okay, I'm going to repeat it for Twitch and let me know if I'm wrong here. The statement was I was working on level 12. I found a buffer in memory as I was looking through it, but I'm not sure how to decode it. Now, I don't have the challenges memorized by number, so I'm going to ask a couple questions here. Is it that the input goes into this binary and it changes it up, and then there's a comparison?
There's no change. It's just that some of them are actually unprintable, so I'm kind of confused on how to get the correct bytes to enter into the program.
So some of the bytes that are being compared that you need to put into the program are unprintable characters. Did you, by chance, use Pwn tools for the shellcoding module?
Yes.
Okay. And did you see how we could do? Let's connect into something here. I'll fire up some random challenge. We are over here in reversing. Okay, yeah, all right. You know what? Okay, so 12.0 is the first one. I do know, okay, I am familiar with 12.0. Because that was one of the things that somebody asked about at recitation. So I did take a look at it. Now, one of the things that we used in shell coding was we used pwn tools, hopefully. I know there are some resistors where they're trying to like use bash, and I respect it, but it's not what I would strongly suggest. And so we have some type of a script like this, and then we do p equals process challenge. Let's see what I have here. Baby rev level 12.0. Now I'm not going to open up the challenge in IDA and figure out what the correct answer is, but we probably wrote some type of script that looks like this in our shell code. Except instead of this being payload, this was something that was like shellcode equals ASM, right? And we let pwn tools build that assembly. But the result of calling ASM was a byte string. A byte string is just any string here in Python that begins with a B. And so if I, for instance, needed to input the literal bytes with value, we'll say 010203, as long as it is a byte string, I can do this. And this is a byte string that begins with the literal byte with value 1, the literal byte with value 2, the literal byte with value 3. And so it's totally reasonable for a program to ask for non-printable characters, but it can actually be a little bit difficult to get them in here. But if I were to do this right here, and instead of p equals process, I'll do gdb debug, and of course, we'll have a p interactive, and I will always forget my boilerplate of context arch equals AMD 64. All right, and so we run something like that. I'm going to break on, let's see if this works, break on read and continue, and then I'm going to finny up from read. I'm assuming that that read is the challenge taking in my input. And if I were to look at the giant hex that is in RSI, what I see here is the literal bytes 1, 2, and 3. Remember that when we're printing stuff out here in GDB, it's going to display it as a number, which is why we see this going right to left, where if we were to look at the pwn tool script that I ran, I was passing it left to right. So that's just a little bit of a gotcha. But if you're using pwn tools, it's pretty easy to get literal bytes and pass them in. Does that get you where you need to be? Yeah? Cool. I want to make sure that if I'm gonna show it, that it gets you unstuck. Okay. Any other things you're stuck on right now that we can just resolve? Cool. Let me check Twitch. Somebody says maybe tell them how to use GDB scripts to reverse. So I like using GDB. I plan on doing that on Friday. I'm going to debug something, maybe even one of the challenges, and reverse it using pure GDB and GDB scripts. But most people's workflow uses decompilers, so I'd rather do that today. Let me just double check here. Somebody asked, I'd be curious to see an example of writing an assembler or disassembler. So we can do that. Was anyone like hard stuck on how to use the decompiler? How to use IDA, change types, name things. Okay, so that doesn't seem to be a stuck point. I'm more than happy to go off the train, but I want to make sure no one is fighting the tool. So this is my level 13, which takes some input, and we have this textual representation of those Yan code assembly commands. if I were to write, if I were to try and write everything is do.py. All right. That's why I'm using IPython actually this semester, because I got tired of having do.py all over the place. I don't necessarily need pwn tools, but I'm just using that as kind of a blanket default here. So what does an assembler do? I said, well, it maps these instructions to literal bytes, right? And this is not going to be like something you're going to see in an algorithms class. This is not going to be efficient code. This is going to be whatever I happen to throw together that makes sense. So I need some type of opcode map, and I want that to be a dictionary. What this is going to be is this is going to map text to bytes. Okay, so IMM is going to map to some character. You can pull this from reversing the Yon85 implementation. You'll see like those checks. You know what? It's a bit of a spoiler, but it's not all the way. You're going to have to help me get there, though. Okay. So I'm going to pull this thing up in IDA. Who's taken a look at like level 13 has some idea of how this bad boy works? Do I got anyone? Any takers? All right. So when I'm looking for this, I'm looking for what is the opcode for immediate. Is that in here somewhere? No? Yes? Okay, so I hear no, I hear yes, I hear it's in the shell code. All right, so let's see. All right, so this one is 13's too easy. I know it's in 19, so I'm going to go all the way to 19. All right, because the challenges start off just kind of hard calling these functions, and they build up to where this assembler and disassembler really becomes useful. So if we take a look at this thing, it has quite a bit different output. I ran it, and it says this level is a full Yon85 emulator. This is why I chose level 19. Right? You have to reason about the Yon code and the implications of how the emulator interprets it. So level 19 has these raw bytes in it. Let's open 19 in IDA. It will complain at me. We just mash OK a bunch of times. I hit tab, and then we figure out where we are. So I'm here in main. All of a sudden, there's like these memory locations that are being set to some value. And then at the bottom, we have bottom of main. Did I bail on main? The bottom of main is that interpreter loop. Let's find that. Interpreter loop.
Is there a way to
I'm sorry. Yes.
Is there a way to open like windows?
The question is there a way to open up two windows in IDA? The answer is there probably is. Do you know it?
My best guess, I've tried it, just drag and drop.
Yeah, like I know I've accidentally done it. Where I've like grabbed something like this and pulled it out and boom, there it is. But then I have no idea how to put it back, so we're just cursed for the rest of this demo.
Drag and hover usually. That's not like drag and hover over there you want to put it back in.
No love. Like I said, that's okay. We'll drive from here. So now we're in this bonus window. We're gonna make the bonus window just kind of go over here. So we have this interpreter loop. The interpreter loop is an infinite loop. It says while one, which is true. So while true, interpret instruction, right? So somewhere in this program, there is the byte encoding, the literal bytes that are going to be interpreted. This is where that assembler disassembler comes in handy. So think about if you were to try and write this thing. I'm trying to write a program that is going to interpret some number of bytes as an opcode. What would I have an infinite loop, makes sense. I'm just going to keep reading bytes. What's the first thing I need to figure out in my program if I were to write this? Or you were to write this? I need to check what the byte is. What opcode, what action is my made-up CPU doing? And if we were to look at this code, what's going on right here in this interpret instruction thing? Well, we see if A2, I don't know what A2 is, if A2 ands with this constant, if it doesn't equal 0, so if that bit is set, then we're going to interpret immediate on A1, A2. Well, if A2 has this other bit set, then we're going to call interpret add. And if this other bit set, well, what is this a mapping of? This is in code, but like what's going on here?
It is mapping those instructions on those behavior and add to the value of A2.
Okay.
Is for the X to do that instruction.
So the statement for Twitch here is it's checking if this byte value is the opcode. And if it is, then we run add, right? And now I'm going to tell you right now, IDA has this a little bit confused. That's just because of the nature of decompilers here. But I'm going to take it at face value. So what I'm showing you will objectively be wrong. But the logic here is going to be good. So I had IMM, and I want that to map to, according to IDA, hex 400000.
That's add.
I'm sorry?
That's add.
Oh, see, this is a good catch. All right, add is going to be hex 400000. Okay. Now you could imagine that I could fill out the rest of this map with all of the actions that I pulled from here. Now I need some type of function that is going to be assemble, right? It's going to take in some string, right? It's going to be the human assembly. And what I'm going to do is I'm going to parse this, right? So I'm going to take the first line. So I will like split human assembly by line. Wait, I'm writing Python. What am I doing? So lines equals that. And then let's assume, which you will need to reverse the binary to know if this is true or not, that the first byte is what the opcode corresponds to. Right? I am basically going to mimic what's going on here. So I'm going to say if, what is this? Add is in the line, then we need some global here that is the, call it assembly bytes, which will also be a byte string. Assembly bytes plus equal opcode map of add. Do you see what I'm doing here? Now, the next arguments to add for an opcode should be the two things I'm going to add, right? So how can I address that? Well, I can maps registers to bytes. Again, this is just a Python dictionary. And we'll say, what registers are in this thing? A, B, okay, so A is a register. And maybe I find out that A encodes to hex 1. Okay. So then we could split the line and say args equals lines split, and we'll split it on a space. arg1 would be args1, arg2 is args2. Because remember, arg0 in this case is still that opcode because the lines has the text there. And then I can do the same thing where I'm mapping whatever it is I get, and I would say assembly bytes plus equals arg1 coming out of my regs. All right. So whatever the text is that was passed here. An example of what my human assembly might be in this case is exactly what, like, let's not reinvent the wheel. Let's use the same basic syntax that this help thing is putting out. So what does an add look like in this thing? I think add AB, right? And so that's the literal string that is being parsed here. And you can see how I could expand these dictionaries to include every register. I could expand these dictionaries to include every opcode. I can expand these dictionaries for anything that changes in the different challenge iterations. So once I have this stubbed out, because I'm going to tell you right now that the mappings of these things is going to change every challenge, I can open up the new challenge in IDA. I know where to look, and I only need to update these mappings, right? There may be, I know there is, like a couple other things that you may want to add as configurations. But at a high level, was this a bunch of code when I said write an assembler? No, it's going to be like 2 or 3 dictionaries, maybe a bool, and then a couple functions. And all you're doing is taking in text and determining what byte corresponds to it. You may have to do some weird stuff with shuffling the order. You may have to do, there may be a couple other minor CS problems that you have to deal with, but it shouldn't be like a 300-line thing. Now, writing a disassembler is doing the same thing, but in reverse. So instead of A going to 1, we say, okay, well, if I get a hex byte of 1, it corresponds to register A. And that gives me something that can print out these Yon code bytes in a way that is human understandable. All right. So like this challenge in particular for level 19, we see that there is interpret instruction. I don't necessarily know what these arguments are, but it looks like this is a pointer to a region of memory. And if we were to go back up to main, what do you think all of this stuff is? Because we didn't pass it any input, but it was like, here's the interpretation of all of these bytes. Here's what the Yon code looks like. Very likely that this stuff up here is the literal Yon code bytes. So if I wrote something that was the inverse of this, right, a disassembler that mapped those bytes to something that is human understandable, my output would be this help text. This is, yes, is that a hand?
Yeah, would it be much more helpful to us if we did write out disassembler rather than assembler for at least these challenges?
So the question was, would it be much more easier to write an assembler versus a disassembler?
No, the other way around.
Or a disassembler over an assembler? My statement here is it's going to depend on what challenge we're talking about. So this is 19.0, which has the pretty help print. 19.1, as you would expect, has no help text. So one way that I could generate this help text is by writing the disassembler for this specific challenge. Now I know that later challenges somewhere between 19 and 22 do the opposite. They say, I'm a Yon code, Yon 85 CPU, give me the bytes to do something, right? And so both are valuable, and the difference between the two is going to be whether I call this function assemble and disassemble, and whether my dictionary or my hash map, if you're more familiar with that term, is going from string to bytes or bytes to string. Functionally, it's the same mechanism here. Right? It doesn't need to be pretty, it just needs to get the job done. Cool? And any questions on the assembly disassembly? Like how you'd approach that? Yes?
Yeah, when we are writing disassembler, I can have, like, if there is a 0, 1, I can have 0, 0, 0, 1. Like, how do I know? How do I account for, like,
how do you
account for, like, zeros? Like, I can have bytes, like,
yeah, I just gotta get the quote the right mark. That is the literal bytes 0, 0 followed by the literal byte 0, 1.
Yeah, if I go other way from byte to string.
Then I can do This.
Right. You need to account for like other zeros as well, like 3 zeros, 4 zeros.
So if the encoding did that, right? If the encoding did encode, for instance, A to 00000001, then yes, you would need to do that because you need to map whatever the actual implementation of the on85 CPU is. Right? Now, I gave made a comment that IDA is in fact wrong here when we look at this interpret instruction, because you're seeing this, right? I told you that IDA is probably the best at generating decompilation, but typing things is hard, right? It's an unsolvable problem largely because all the assembly has is memory addresses and then accesses. And so you don't necessarily know, is this really? It says it's an int. So IDA thinks this is a 4-byte value. Doesn't mean it is. Like, we could hit Y here on like A2 and say, instead of this being an int64, this is now a byte. And it doesn't like me. All right. Well, what about, you want int 8? Okay. I made it an int 8. Now it looks considerably different. I'm not saying it's better if A2 plus 2 and 8, right? So as this is just, I told IDA, I think this is a byte. IDA's like, okay, we'll roll with that and we're going to adjust and shift things. Is this the right interpretation of what's going on? I don't know. Is the 4-byte one the right interpretation of what's going on? Like, that's part of the reversing process. My suggestion for figuring that out would be, don't rely to the nth degree on the pseudocode. Right? We're looking right now at this kind of mystery line. If I hit tab and jump back, oh no, I can't jump back because my assembly is now hiding in this thing. This is how we ended up with the cursed demo. All right. Yeah, we'll just close all of IDA and see. Leave me alone. Reopen it. So if I instead just have my one window, and we go and find, where is that thing? Interpret instruction. If we go to where that is occurring in my pseudocode and I do the reverse, I hit tab, it jumps me to that comparison. Just from this line that I'm on here, and a couple above it, I have a pretty good idea of what the type actually is. Hopefully you do too, being somebody that has a bit of experience looking at assembly. Now, there's two ways that you can deal with that. I could be like, okay, I know what it is, and I could try and fix the types here in IDA, right? And get IDA to make something that looks more C-like. You can certainly do that. But if I just know it, is it worth the time of me fighting the tool? No, I already know what I need to know. Let's not try and fix it up every challenge. Let's just know that IDA is wrong about what it's showing me. Any questions about what we saw here and how we know IDA is wrong? Again, we put our cursor on the line, we hit tab, and we looked at what is the corresponding assembly, what is actually going on here. It is working with a 32-bit register, but if we were to look a little bit higher, what is actually in that 32-bit register? It's pulling from some location in memory, and it's only moving a byte. And so that comparison is actually a byte comparison, not an int, as IDA initially thinks here. Now, getting IDA to spit out more C-like code is a lot of work. Of going here and renaming this. So this is A2. If I hit N for name, we believe this is the opcode, right? All right, I have opcode. Well, if I want to change the type, because now we believe it's a byte, let's see if uint8 is a thing. No. I'm not an IDA user here, so let's try just uint8. Nope, no love. Does Twitch have it? Is my favorite troll going to save me?
Unsigned underscore and 8.
Well, I'm sorry. What did you get?
Sure. Byte 14. Unsigned underscore 8 and 8.
Ah. Unsigned int 8. There we go. But again, it's still, IDA is trying to make this make sense. And so you can get these like weird casts and double casts and things like that. That isn't specific to IDA. That is just the nature of working in these types of tools. And so you can fight it, and it's definitely worth it in some cases, but in a lot of cases, it's not worth the time, in my opinion. Especially when you can use GDB or dynamic analysis to complement your understanding here. I'm going to double check here on Twitch. I'll make sure there's no questions about that. But one of the things that I really want to show is these three things right here and thinking about bytes. So let's see what Twitch had. Took me 2 minutes to figure it out. So somebody's really clever, right?
Video editing you like?
Let's see. All the video. So somebody says it was mad. Okay, we're good. So one of the comments on the Discord that has already happened was thinking about bytes and how it's interpreted. And that was where that question that we kind of opened with from the audience here, from the class, was how do I send these unprintable bytes? Well, if you are still committed to Bash, right, you can do what this meme says here, where if you were to echo and you just quote this and say /x00, that's going to send the literal characters /x00. So you're sending 4 bytes. You're actually sending 5 because echo implicitly sends a new line. Right? That new line character thing is going to get you several times. In Python, and using pwn tools, your difference is send line versus send. Be very aware if you're passing that or not. Now, if I'm using a byte string in Python, as I just showed, we can use these escape codes, and this is the equivalent over here using echo. So echo-e would interpret that escape sequence as a null byte. It would send how many bytes?
1.
You're wrong. What did I just say? Echo implicitly does. It adds a new line. It's actually going to send 2. So this is actually incorrect. I don't know why this guy's happy. Because his exploit didn't work. That would actually send a null byte followed by a new line. And if you read the man page for echo, you can tell echo to not send a new line. The flag is -n. So if for whatever reason you wanted to use echo, which I'm not encouraging, what you really want is echo-ne, and then your string with escape sequences. Now, one of the discussions on the Discord was about this exact problem. They weren't necessarily using echo. They weren't necessarily using Python, or it wasn't a pwn tools issue. They relied, Twitch says -n means no new line. They weren't necessarily using the wrong thing on the dojo. They were looking at, I want to say level 12, but I could be wrong there. Or maybe 13, but they were looking at something where there was a bunch of manipulations going on, right? It was kind of like a crack me just packaged up in this Yon 85 stuff. And instead of using the kind of in-house programming language tools, they were using the Microsoft Programming Calculator, which I've never used. And I didn't know. I kind of expected it to be an online like hex thing. There's a lot, if you just type like do byte manipulation into Google, there'll be a bunch of websites that just have magic text windows that do stuff. That stuff is like scary. You can't trust it. Do you know what that website is actually doing? This is like a very precise science, right? And if you don't understand what the tool that you're using does, you're just in for pain. And so my recommendation is to stick to using pwn tools or using Python, because that is something that is going to be programmatic. It's something that's going to be repeatable. It's something that you can show, like you can show a snippet of what your code is doing, and we can be like, here's where the misunderstanding is. I believe it was in the on topic, somebody pointed out that I guess that Microsoft Calculator by default works on keywords. So 8-byte numbers instead of individual bytes. And because of that, the way it was doing all of the math was incorrect. Versus if I just use Python and say I would need to XOR something. I can say I have 14 and I want to XOR it with, I don't know, 2. There's my number. This is a decimal number. If I wanted to, for whatever reason, see that in hexadecimal, we can call hex on it and get that value. The nice thing here is that since this is a programming language, we can do all of this in a script that is repeatable, it is testable, it is manipulable. Instead of, oh, I made a mistake punching a bunch of things in Microsoft's calculator, and then I have to do it over again, right? We can just run it, fix it, run it, fix it. We can iterate on our kind of process. How do I clip Twitch? I don't know what you have going on over there, but we'll see. All right, so the other question that was kind of related to bytes was, how do I think about types, right? I want to send this as a string, or I want to send these bytes as an unsigned integer. I need this to be an integer. Does anyone know how bytes relate to types? I tried to articulate it, but I probably did a poor job. So bytes are the truth. If I run this challenge, and I'm just using it because it's something I can debug, right? And if I examine the giant hex at RSP, I get this value. This is interpreting these bytes as an 8-byte hexadecimal number. If I examine it as a decimal number, I get this. If I want to examine it as a string, I get this. Did the bytes change? No. The bytes just exist in memory. We're the ones that choose to interpret it one way or the other. And so there isn't like I need to write these bytes, but it needs to be an int. If you know how to represent an int, which an int is just 4 bytes, any 4 bytes can be an int. Now, you can't make the program think it's an int, but you can give it 4 bytes, and if the program wants it to think it's an int, then it is. Is that a hint?
Yeah. Does GDB have a way to just display like all potential ones? Like, is it an int? Is it a string? Like all at once at the same time?
So the question is, does GDB have the ability to print out all of the possible interpretations of something all at once? You could write a little GBD script function that does this. It would be like 5 lines of GDB script. Like if we're being real here, I don't think that's worth your time, because there is in fact like a correct way, right? And the thing that informs me about what is the correct interpretation is what if I have the pseudocode, maybe Ida's right. But alternatively, I just happen to be here and read. This is a CMP instruction, right? So that's going to perform this comparison. That tells me these two values are being checked against each other. This is a 64-bit comparison. And then based on the result of that comparison, here's my conditional jump. What is JA? All right, somebody said jump above.
Unsigned.
And then somebody else said unsigned. Okay, what if I don't know that? How do I find out what JA is? Like, what would you do?
Codes for jump, like just the instructions.
Okay. So one was Google it. I didn't hear ask in the Discord, but that's probably for the best. One of the great resources on the internet is Felix Cloutier, no relation, just like Ryan A. Chapman, right? Random person on the internet that just put up an awesome resource. And so in general, if you type into Google Felix x86 and then an instruction, his page will be, or their page will be the first hit. And it's insanely detailed information about like every x86 instruction. Now, what we were interested in was JA, and JA will jump if the carry flag is 0 and the carry flag is 0 and the 0 flag is 0. And if we scroll down a bit further, it should describe whether or not it's interpreting things as signed or unsigned down here. Did you see it? I can't control Z. Felix, x86, JA. We were down here. Where were we?
It is from the top. It is
Third paragraph. The condition for each JCC mnemonic is given in the description column of the table in the preceding page. The terms less and greater are used for comparisons that are signed integers. Above and below are used for unsigned integers. So it was hiding in there. I like pointing this as a resource because regardless of what your how specific, hyper specific your question is, the answer is probably on here. But you could also just Google or ask Sense AI. It's probably something that is generally available on the internet. But Felix's site is a fantastic resource if you want to get into the nitty gritty. So what we know here is this is a 64-bit comparison that we said was unsigned. So now do I know what the type of this thing is?
I'm a little bit confused about unsigned. So are we interpreting operands as unsigned or result as unsigned?
So the comparison is comparing the value that's in RAX to this constant. Right? The result of that comparison will set the flags in GDB. This right here, this CSSS. No, that's not what I want. E-flags. E-flags is the flags. So every time that a compare instruction is executed, the actual implementation of that is not that there's a true false. Okay? What compare and test actually do is they take the two values. I want to say they AND them or they subtract them. It's one of the two, right? Subtract?
I think so.
All right, somebody's pretty confident it's subtract. I just go ask Felix, right? If I really wanted to know what it was. But the result of that that operation, based upon the result, it sets these flag bits. So in the CPU, there is another register that is like the flags register, right? We don't directly set the value in the flags register. The flags register is influenced based upon comparison instructions, test instructions, those type of things where we're trying to conditionally determine something. Since I have Jeff installed here, we see that the 0 flag is set, the parity flag is set, the interrupt flag is set, because they're larger and more bold there. In practice for this course, you probably don't need to drill down to that level of detail. But if you were like, hey, how does this thing actually work? That's the answer. Instead, we can just look at the instruction and say, this is a 64-bit comparison on whatever is RAX. And then what we care about is the result of the unsigned comparison. So this is a 64-bit unsigned comparison that is happening inside of read. This is just an arbitrary location where I happen to be broken.
So it is interpreting that hex FFF as unsigned integer opposed to negative.
Correct. So the comparison itself isn't the one that is making it. The statement for Twitch was this FFFFFF thing. Is that an unsigned or signed? And the answer is compare actually doesn't care, right? Compare just knows bytes are bytes. So compare is going to perform this operation on whatever bytes are in RAX and whatever bytes FFFFFFO is. It doesn't care whether it's an unsigned or signed. It's going to perform the operation on these literal bytes, and it's going to set those flag registers that I have now got off the screen. And then based upon how those flag bits are set, will influence whether the jump above occurs, we actually jump, or we do not. All right. So this is, you can think of it as tester compares gathering information about the two values, and then the jump is what is determining what we're actually looking at. These are good questions. Anyone have any other questions about what I'm going on here and how I can reason about the types of what's going on? Somebody says types don't exist at runtime, which is true. There just are a convention about how to like reason and think about things. Yeah, bytes is ground truth. Cool. So one thing that let me double check here. Okay, one thing I really want to get to is if I am in IDA and I look at a location here, right? I have this instruction inside interpret instruction. I have LEA is super tiny, at least on my screen. But down here, you can see a location, right? A representation of where this is in the binary. So we can use this location to inform us if I want, what if I want to throw GDB at it and I want to break right here on this move EAX 0. Well, one of the problems that you'll inevitably run into, we run checksec on this. We aren't, disabling anything now. We're functioning in what is modern Linux security here. So that means that we have the binary is compiled with PIE. So that means your addresses are going to change all the time. If I run GDB on this challenge, and we print RIP, I get FB F5 DD6. Let's run it again. I'm at the exact same point in execution, and all of a sudden it is D45D DD6. So the bytes there change, right? ASLR is enabled. We saw this in memory corruption. Well, that's horrible if I want to debug, right? Do I have to hard code all of these things? Especially if this thing is stripped. Let's make it harder, because you could be like, yeah, Robert, but this said interpret sys. I could go, or interpret instruction. I could go to interpret instruction plus something. I got this. But the 0.1 levels are stripped. They don't have symbols. So now I can't even reference that. Remember, this is an almost identical binary. But one of the key differences here is this thing is stripped. Come on, Ida. So now I don't have these nice names. And everything that you see here in IDA, aside from main, is just kind of an IDA invention. But this looks very similar to that level from 19.0. So this is my interpreter loop. If we go over here to the assembly, let's say I want to break at right here, move 0 extend EAX AL. If I sneak a peek down here, IDA says 1B-A7 in hexadecimal. That is an offset into the binary. However, I don't know where I am in this thing. As I showed, the addresses change. So what can I do? Well, GDB does not disable randomization for binaries that are set UID. And all of the challenges are set UID. That's why we see that S up there where the execute could be. How can I make this not set UID? I could just copy it somewhere else. And if we look at the copy of it, we see that that copy does not have the set UID bit set. This means if I run this thing in GDB, somebody says no way. Yeah, way. Okay. So now I am at this thing right here. Let's try it again. Oh, wait. Am I debugging the challenge? Ah, it didn't look right. That's why I was like, wait a minute. Let's debug the copy instead. And now I get something that I've seen before here, right? That address is fixed, 55555. I get something that looks a bit more constant. If I were to run this again, do the exact same thing, I get the exact same address. So now this is repeatably debuggable. I can't get the flag on the copy, but the copy is going to behave the same way as that set UID one. So this is one trick you can use to make that just not be a pain. Now, the other thing is I said this is stripped, right? And so sub 1B73, what IDA has decided to call this, isn't real. If I were to try and debug my copy here and I said info func, what did they call this? Sub underscore, there's no functions named that. IDA just kind of made it up. So what if I want to get that breakpoint, right? I want to look at something in IDA statically and then use that to inform what I'm doing in GDB. Perfectly reasonable ask, right? Well, we can do that. I'm just going to ask that you copy that third line from my GDB init, which I ripped off of Yon years ago. All right, this is just a huge time saver. There's this magic constant. And what I'm doing here in my GDB init, remember home directory .gdb init, what .gdb init is a series of commands that are ran every time GDB starts. All this line is doing is creating a variable named base with a constant value in it. The reason this constant value is useful is if I run VM map with Jeff, if you don't have Jeff installed, it's info proc map. We'll give you something similar. This shows me all of the memory for this process. That constant is the beginning of where this ELF is loaded into memory. And as long as the binary is not set UID, that will always be true. So let's bring this together. And I'll use this to set a breakpoint at like an arbitrary location I have found. Oh, IDA here, what was I looking for? Move 0 EAX EAX. IDA says 1BA7. Let's examine the instruction that is at base, which is pulling from my GDB init, plus, what does IDA say? 1BA7. What do you know? It's that exact same spot. So let's set a breakpoint there. We can do that. And then let's run it. Where am I? Exactly where I saw in IDA. The key points here. The binary is not set UID. So copy it over to temp. There is a way to disable it in Pwn tools. I'm not going to show that magic. This is simpler. And then get that base value in your GDB init. What that lets me do now is I can look at the decomp of one of these binaries. Maybe I cleaned it up a bit, but I find some point that I'm interested in. And I'm like, well, what's really going on here? Or maybe I want to find, is this really a byte pointer? Right? What's really going on in memory? This is something I want to see live. We can find the line that is the assembly, we can set the breakpoint in GDB, and we can look at it ourselves. I really like falling back to GDB. And so that's something you'll see me do a lot. Now, if you're using a tool that is not IDA, one thing to be aware of is some decompilers will arbitrarily base the binary at some offset. And so you really only care about the first 2 bytes of what you see here, the least significant bytes. Some decompilers will throw a 2 over here, several bytes into the memory address. That is a setting that you can change on the decompiler, but instead of tweaking the setting every time, if you just know to ignore this 2 that's way off there, then you'll get something that's correct. And you can do that same thing using Ghidra, anger management, etc. All right, what else did I have on the slides here to rock and roll? So I showed you how to kind of deal with stripped binaries, right, by using base so that you can find these things, how to not suffer through ASLR, retyping things in IDA. I did say it. Does anyone know what the magic key is to change the type of something? Y. Y for type, N for name, tab to jump back and forth. This isn't what I said I was going to do on Tuesday, where I was going to try and reverse another emulator, but hopefully these are more real things that you can use tonight when you look at the challenges, tomorrow when you look at the challenges, etc. One of the things that I did not have time to make a slide for, but is worth mentioning, is one of the questions, I think it was you asked, yes, moi. You asked, would there be extra credit opportunities for attending certain events, right? And my answer was no, but we'll play it by ear. So I have to check my phone because I was going to make a slide with this announcement. In the ASU Discord, there is an individual named Mahalas. And there is a kind of undergraduate-facing CTF competition that's going on. And they are forming a team of undergraduates to just try and play this CTF, right? It's not exceptionally difficult. It is meant for, or kind of targeting people that are newer to this. Check the Discord for details here. It looks like it starts tomorrow at 1 p.m. If you show up to that, Mahalas is going to give me a list of whoever shows up. I don't care if you solve anything. I don't care if you can only spend a little bit of time there, right? Show up, give it a fair try, let him know who you are. I'll give you 1% course extra credit for giving it a shot. Okay? Now, that doesn't mean show up, shake his hand, and dip out in 5 minutes, right? Like try and be reasonable about it. I'm going to leave it at his discretion as far as what is, a fair attempt. All right? Go there, sync up, make sure he knows that you're there, see what's going on. One of the questions that I know is coming is, I'm a grad student. What's happening? No? Oh, different question. What do we got? Oh, what's that?
For the CTF, just join the ASU Hacking Club because it kind of got mixed. So if you just join the Discord on the Hacking Club, you can know what time and where we are coming.
Okay, so the comment is that there's ASU Hacking Club, because I know some people have asked me outside of the stream or outside of class, hey, I'm interested in this stuff. I want to try and do it as a hobby. I want to, meet other people that are interested in this and not have the pressure of, the looming class thing on here, right? I want to see what the kind of the hacking scene is more like when you're doing this binary exploitation stuff. And a great way to do that is to play CTFs. My initial answer outside of class was that I didn't have a strong answer because I needed to get information from the ASU Hacking Club and kind of make sure I wasn't pointing people in the wrong direction. But this is a great opportunity to see what it's like, practice some of those skills. I believe it goes on for a little while here. Okay, you have details. I don't. I got this literally as I was driving up, and I was like, yeah, all right, let's.
Where's this written?
It's written on the pwn.college Discord, in the ASU channel.
Oh, just
in the ASU channel. I'll link to it and the announcements after class here so that everyone has it. All right, show up, give it a fair shake. I'm not asking, did you solve anything? Just go there, see what you think. I'm not going to make you write an essay. Just get your head counted. You'll get 1% extra credit flat on the course. Seem like a fair deal? Yeah? Now, as a kind of counter to that, there is that checkpoint, right? The checkpoint's on Monday. And so that's kind of mean of me to be like, oh, go play the CTF and the checkpoint's Monday, right? That seems a little unfair. So what I'm going to do, and I'm going to trust that everyone that decided to stick it out in this course can manage your time. I'm going to move the checkpoint to the same as the deadline. So that way, hopefully, you can do the CTF, and I'm not doubling you down on time here over the weekend. You can allocate your time as needed, right? If it runs for several days, my requirement is just give it a fair shake on any one of the days. If you enjoy it and do it all, that's awesome, but I don't want this extra credit have fun thing to go hard knocks against your grade here. So I think that's a fair way of doing it. Gives you an opportunity to give it a shot, get some extra credit right now. Good? Question.
Can you repeat where we can find the CPM again?
So the details are on the pwn.college Discord. If you scroll down, there is a generic ASU grouping. It says ASU-general, and then the exact chat channel is called chat. As soon as I'm off the stream, I will post it in the announcements channel for 466 so that everyone gets it. All right. Does anyone? I've got like 2-3 minutes left. Does anyone else have anything for me? I know the checkpoint hasn't been updated. I'll do it later tonight. Yes.
Can we assume between the 0.0 and the 0.1 challenges that the structure is similar? Like the same functions are being used in the same places?
The question is, for the reverse engineering challenges here, there are 0.0 and 0.1 versions. Can I assume that it's the exact same functions in the exact same order? The answer is no. All right, it's going to use the same building blocks, so it'll be functions you've likely seen in the 0.0, but you do not have a guarantee that they're in the exact same order.
Like, for example, in the 0.0, if it was anding the flag, but in the 0.1, it would XOR the flag.
Okay, the question was if in the 0.0 it was anding some bytes of the flag, it could 0.1 XOR the bytes of the flag. The answer is yes.
Okay.
Right? That's part of what we're trying to get you to reverse engineer and identify. So you use GDB, use IDA, use whatever tool makes sense to you to hopefully identify what those things are. For these, like 13 is a good example where there's just these kind of magic functions. I do think IDA is a great tool there because once you rename one and you're like, well, what this function really does is it adds something or it XORs something. You can get a representation of what the order of operations are pretty quick. That'd be how I would try and tackle it at face value. If I rename these things so that I know what's going on, then I can just read it down the line, write something similar in Python, and get what I need. Anything else before I end the stream? I'm going to take a look here at Twitch. It's fine. We don't have symbols. Don't debug them. All right. So somebody is passing some positivity here, saying, "Use Jeff. You can do it. Raw. Right? I believe in everyone that's here. You decided to stick it out despite all of my warnings. We're gonna have an awesome semester. Thank you guys." I didn't hit the button.